Let's place our first structure. We're going to place a curb inlet down here in the lower left corner of our parking lot, adjacent to the island. So I'm going to go ahead and zoom in to that area so that I can see the edge of pavement and the curbing and so forth. And there's where Geopack determined the low point to be. So I'll go ahead and access the drainage pull-down menu under Component, Node, and here's where we can add nodes, access the tool to edit nodes, delete nodes, change the name of a node. So I'm going to go ahead and do node add. And here you can see that it uses my default naming convention from the preferences. I can give it a description if I like, that's optional. And I'll click OK. And then I get the node configuration dialog. We're going to work through our options here on the left hand side, and when we're ready we'll click Apply to add it to our project file. We also have icons located across the top to do the same thing that we saw in the pull down menu, to add nodes, delete nodes, to rename nodes. So we can access the tools right from the node dialog. And in fact, this is the same dialog we will use later on if we need to make changes to a node. So the first thing I want to do is choose the type of node I'm going to place. Again, these are the types available from our drainage library. And we're going to use a curb type, and it's in a sag condition. So we'll choose sag, and then the type, the library item. Here are available inlets that can be placed in sag condition, so we filtered the library to show you just those. And in my particular case, I want the 10-foot curb type A. There's the graphical representation of it. Now, where do I want to place it? At the low point, so I go to the Location tab, and we have various methods to place it. We can place it relative to an alignment from our Kogo database and a profile, or we can just place it at a particular point. You also have the option to place it tangent to an element or tangent on an element. So we'll do tangent on an element. When you use that option, tangent on element or tangent to, well, that requires you to select the microstation element that you want to be tangent to. So we're going to select the gutter line, so you might want to zoom in and select the gutter line and accept it with a data point. Now if you choose the Station DP button and you come into microstation, you can see that the inlet is locked onto that element, and as you slide it around. So I'll zoom back out a little bit, and you can see the structure. Now you also have options to change the angle, mirror the node. So for example, if I want to turn it 180 degrees, now you can see it's on the other side of the line that I selected. So I'll go ahead and just data point where you want the inlet to be. And now you've placed it. Now you can always change it. You can come back here and just replace it. Nothing's set in stone until you click Apply, and then you're just updating after that. So tangent on element, and we selected the microstation element, which was the invert of the curb, and then placed it. Spread criteria, again we can compute spread calculations here, ponded widths and depths. So we just need some general information. What's the slope coming in from the left hand side? What's the slope coming in from the right? So we need to key those values in. And here we're going to use 2% slope coming from the left side, and we got about a 0.5% slope coming from the right. Percent discharge left and right, I'm going to say 10% from the left and majority 90% from the right. And then as far as the spread cross section, what's the conditions of the pavement coming into the front of the structure, and I'm going to say that's for 63 feet. I've got a 2% slope across the parking lot there and a Mannings of 0.012. We also can key in the allowable ponded depth, which I'll say is 0.7, and the allowable ponded width of 15. Now, in order to calculate spread, we need to add our entry that we keyed into the bottom of the dialog to our list. So click the Add List Item icon. Elevations. We're going to reference a surface to establish the elevation of our catch basin or inlet, and that's going to be based off the model tower. Elevation source, we could reference the model that we just are going to use, and it happens to be 5267.864 in that location. Or, again, you can always use or key in your own value. So the elevation of the top of the structure. Now the node elevation option, we're going to use that as set that the same as source. But if you're calculating the elevation, and you happen to be calculating the elevation along the back of the curb, well then maybe your node elevation or the point where water enters the structure would be an offset from that. 0.5 down or whatever. You can also use or supply that elevation. So this would be the hydraulic elevation point and where the spread section starts from. As far as aligning pipes coming in and out of this structure, we're going to match soffit and set that to a minimum depth of 3 and a maximum depth of 10, and that becomes our allowable pipe envelope for this particular structure. And every structure will have a minimum maximum depth, which then Geopat can use to help design the profile of our conveyance system. Junction losses, we're going to use the defined equations from the drainage library, and discharge, we're going to use the computed discharge that we compute off of our drainage area. Now we've not yet created a drainage area for this particular inlet, and that'll be our next step. Under computations, you'll see that there we can't perform any inlet computations unless we have a drainage area that gives us the runoff. At this point I'm going to click apply, and this will add the structure to the system. And you see once I click apply, our project preferences have set it up to label the structure. So we've labeled it so that indeed you know that that's catch basin 1. Next we'll go and create an area.